that me, as your magician, I'm actually going to let you know, I'm going to let you in on some of the secrets behind my tricks. All the secrets are behind, chemistry is the foundation behind all these science magic tricks I'm about to do for you. So, let me get something real quick. Since I have that wine glass, I need something. Alright, so for our first magic trick, have you guys ever heard of turning water into wine? Alright, well we're not going to quite do that, but it's going to look like we can do it, so let's just pretend that we did that. So, I'm going to need a volunteer to come on stage. Anyone? You want to come up? Alright. Perfect, you're already safe. What's your name? Hudson?
Hudson.
Hudson. Alright, everybody give a round of applause for Hudson. Alright, Hudson. So this stuff right here, this just looks like water, doesn't it? Looks like water? Alright, well, I guarantee that it is not water. Now what I want you to do, on the count of 3, see if the audience can help us out for this. It's a little bit windy today. Alright, so safety first, right? Alright, so if you could hold this beaker for me, right? Alright, let's go up here so everybody can see us. On the count of 3, I want you to pour that beaker into here. Can you guys see? Alright, so 3, 2, 1. Ooh. So there you have it. Good job, Hudson. Thanks. You like science? He's going to be a future scientist one day. You can head down. Alright, so to understand what happened with this trick, you need to know a little bit about acids and bases. You guys have probably heard about these. Acids are a lot of things that you find in your foods. Some things are like orange juice, vinegar, lemon juice, a lot of things that taste sour. Well, what happened here is that we had the opposite of an acid, which was a base. Bases are things like soap and bleach, detergent, stuff that you don't want to be eating. So what we had is that this solution right here was a base, and what I did is I snuck a few drops of a chemical into this, and when we poured in a base, it turned this blood red color, which kind of looks like wine. So if you ever want to impress your friends, ask me about it, and I can teach you how to turn water into wine. So, for our second trick, set up a couple of solutions here.
Oh, I know how to do it.
Again, these look like clear solutions, but what happens is that one of them has a chemical dissolved in it, and the other one has another chemical dissolved in it. But when I mix them together, it makes a different chemical. A chemical reaction happens that produces this yellow precipitate, which is a solid that forms. And I'll set it right here. You guys can keep an eye on it. And what will happen is after a while, there'll just be a little pile of yellow powder sitting in the bottom of this. It's not actually dissolved at all anymore. Alright. Alright. So speaking of solutions, solutions are when you have one chemical that's dissolved in another. That's all it is. Common examples are things like soft drinks, Kool-Aid, stuff you see in your everyday life. So, I'm just going to pour myself a glass of acetone, cold and refreshing, you know. Oop! Clearly that's not going to work. And actually, if you look at it, this is a styrofoam cup. If I swirl it around a little bit, it'll be completely dissolved in acetone. So this is a solution that you probably won't encounter in everyday life. Yeah, acetone will dissolve styrofoam. So Next time you want to pour a glass of that, don't use styrofoam. You guys might know if acetone is your mom's nail polish remover. So just keep an eye on that. Set it right up here with our powder. Alright, for our next trick, we're going to start talking about gases a little bit. Now I'm going to need 2 volunteers. So, see you, and you in the red back there. I got nothing. Yeah. All right. Step with you guys. What are your guys' names? James? James and Polina. Everybody give a round of applause for these guys. All right. So if you guys come up here, we're gonna do our next trick, and you guys are actually gonna do this trick. So I'm gonna hand each of these to one of you. All right. So what's going to happen is on the count of 3, if the audience, if you guys want to help out, these guys are going to pick up their balloon and just hold it directly above the flask here, and we'll see what happens. Not yet. Oh, right, you can go do yours too. 3, 2, 1. Let's give these guys a round of applause. As you can see, there's another chemical reaction that's happening here. But instead of making like a yellow solid like we did in the last one, this time, you guys can head down if you'd like. Thank you. What happened in this trick is that I had baking soda inside my balloons here and a little bit of vinegar in the bottom of these flasks. And when they turned them upside down, the baking soda fell out, reacted with the vinegar, and produced carbon dioxide gas, which is inflating these balloons right here. So, it's a cool way of seeing that gases can be produced from things that aren't gases, which is something that we commonly see in chemistry. Let's see. So this looks like there's a lot of pressure inside these balloons, and what I want to demonstrate right now is how much pressure actually is released. So here's some baking soda, and here's some vinegar. I'm going to fill up this film canister with a little bit of baking soda if I can get it out. And some vinegar here. Oops. Oops. That didn't work. Try it one more time. That's to wait for a little bit. It's going to make a loud noise here. I promise it'll go. Sometimes it takes a while. If you look at this, it's actually like bulging on the sides here with so much pressure. Take my word for it. Okay. Well, let's pretend that just happened. Hey! Thanks for the support, I need it. Alright, so for our next demonstration, I have here some liquid nitrogen. Now nitrogen, as we usually know it, it's a gas. Thanks. Nitrogen, it composes most of the air that we breathe. You would think that most of the air that we breathe is oxygen, but it's actually nitrogen. Well here, if you not freeze, but get it really cold, nitrogen will turn into a liquid actually. Pour it right here. This is really cold. It's negative 320 degrees Fahrenheit, which is colder than anything you've ever felt, and anything I've ever felt either, because I don't want to touch this. And as we always say, safety first. I have this glove on here that's padded and protected to give me some insulation here so I don't freeze my hand off. Well, a cool trick I want to show you guys is I have a bunch of balloons here. And I have about like 7 or 8 of them. Do you think I could fit all these inside this little container? Think so? You think so? Well, let's see it. There's 1, 2. 3. 4. It's like they're magically disappearing or something. 5. 6. 7. You guys get the picture. I can keep doing this, but I'm out of balloons. And if we actually take these back out, you'll see that they have completely just crumbled up. I can set them here and they magically reinflate. Take them all out for you. So you guys have any idea what happened here? Like, what do you think in the front row? They deflated? Why do you think they deflated? It is, that's right, it's because it's so cold. This nitrogen is so cold that when I put a balloon in it, all the air that was in it stops, inflating the balloon, and the temperature makes the pressure decrease. And it looks like the air almost completely just disappears. And then when I take it out, it heats back up to, it's beautiful 75-degree weather or whatever it is out here, and they magically reinflate. So that's a little bit of the idea behind the way gases work. Now let's see. I'm going to need one more volunteer here. You in the back in the yellow hat. You come up over here. What? Looks like we got an LSU fan. What's your name? Jack. Nice to meet you, Jack. Well, I've got a present for you here. You can step up front here with me. Right up here. Alright, I would like you to put this glove on for me. Alright, now touch these flowers for me. Look like regular flowers? So they're regular flowers, right? Alright. What happens if I dip these flowers in the liquid nitrogen? Let's see what happens. You want to take a look in there real quick? What does it look like? They're not losing their color. What's happening is that you see all those bubbles in there? Those bubbles are because the flower is really, really hot compared to the nitrogen. So what it's doing is making the nitrogen steam up, just like water does when you cook it in a pan. Alright, so what I would like you to do is hold this out so everybody can see. I want you to just grab these in your hand like you would and crush them. Completely crumble them. There you go. Alright, good job, Jack. Thank you. You give me a glove back. Thank you. Jack, I got a present for you. You come around the front. You take this home, give it to your girlfriend, give it to your mom, whatever you'd like. So what happened here in this trick is that the water molecules that make up most of the flower petals get frozen when you put them into the liquid nitrogen. So that was essentially just like crumbling like an icicle in his hand. It was just so brittle that crushing it, it's all the water had turned to ice. So that's it for liquid nitrogen. I've got one more trick for you guys, and it's pretty cool, assuming it works. So let me move everything up front here. Alright, so this is another chemical reaction. Some people have given it the name elephant toothpaste. I don't know if you guys have heard of this before. They call it that because it produces enough foam that it looks like it's toothpaste that only an elephant could use because there's so much of it. Alright. So, got a chemical here. Pour it in here. Alright, for this I'm going to want to put some gloves on for safety, which I conveniently have here in my pocket. Oops. Looks like I got the wrong size. Alright, now normally this reaction will work without some dish soap. I'm going to put some dish soap in here to make it look really cool. Why not, right? Yeah. Alright. Let's see, it's a... Give me the hydrogen peroxide. Yeah. Woo. Alright. This is concentrated hydrogen peroxide. It's a lot stronger than the stuff you guys would use if you have a cut or a burn. This stuff is 30%. The stuff you have at home is only 3%. This stuff is so strong that if I get it on my skin, it would probably kill my skin cells. So I don't want that to happen. Now, if I pour enough in here, I'm going to have a big reaction take place. And let's set this up here so you guys can see. You guys ready for this? It's the grand finale. Count of 3. 3, 2, 1. Come on. There we go. Woo! That's supposed to land in here. It's just foam, it's just soap. And that'll keep going for a while. What's happening here is that hydrogen peroxide is, you guys might hear of it as H2O2. It's kind of like water, but it has an extra hydrogen. And with this reaction, it's releasing a lot of oxygen gas, which is making the foam happen here. And hydrogen peroxide just turns into, it's getting really hot too. The hydrogen peroxide turns into oxygen gas and water. So after a while, this will be fine for me to touch. So, if you guys have any questions, feel free to ask me after the show. That's it with me. I hope you guys have a good day and enjoy the Science Expo. So thanks.
All right, everyone give a big round of applause for Jackson.